Next, we'll try a few problems combining the different properties of radicals that I know so far. So for this first one, I'm doing 6 times the square root of 28 over 9. First of all, I would check to see if 28 over 9 reduces, which it does not, so I won't simplify that fraction. Then I'll use the quotient property and split this up into the square root of 28 over the square root of 9. Now, the square root of 28, I'm going to use my product property, and I'm going to do a prime factorization of 28, which is 2 times 2 times 7, or 2 squared times 7. And I'm kind of combining a couple steps here. I used my product property, and I also knew that when I multiply fractions, I multiply the two numerators to get one new numerator. I'll do the same thing with my denominators. 1 times the square root of 9. Square root of 9 happens to be 3, so 1 times 3 is 3. Now the square root of 2 squared, remember these are inverses, so they cancel each other out and just give me a 2. So now I've got a 6 times 2 times the square root of 7 over 3. 6 times 2 is 12, and 12 over 3 reduces to 4. So my final answer for the first one is 4 root 7. Right, now I'm ready to try the next one. The square root of 76 over the square root of 25. Again, first I would check to see if 76 over 25 reduces, which it does not. So now I would work on simplifying both of these separately. First I do the square root of 76, which is 2 times 2 times 19. So 2 squared times 19 is 76. And the square root of 25 just works out nicely. It's just a 5. The square root of 2 squared, squaring and square rooting are inverses, so the square root of 2 squared is just 2. And 2 over 5 does not reduce, so this is as far as I can go with that second question. Now my third question here, I'd want to see if anything reduces, and this time it does. This second fraction, 18 over 3 reduces to 6. So this becomes the square root of 12 times the square root of 6. And 12 times 6 is 72. And the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Now, I'm going to put this as 2 squared times 3 squared, and then I had an extra 2. It was 2 times 2 times 2 times 3 times 3. And remember, I'm trying to split them up into things that simplify nicely, so I'm putting my perfect squares together. The square root of 2 squared is 2, the square root of 3 squared is 3, and then I still have that root 2 left over, and 2 times 3 is 6. So my final solution for that last question is 6 root 2. Now, as I've mentioned before, depending on the order that you decide to apply the properties that we've learned, your work might look different along the way, but you should get the same answer even if you use the properties in a different order.